This lesson I'm going to do a little differently. I'll be reading some of this word for word, not for the purpose of insulting your intelligence. I know you guys can all read, but I want to read it with emphasis on certain points that I know will be important for the quiz and for your understanding of this material. So here it goes. The big idea. Computers are binary. Everything is on, off, low or high, 1 or 0. There are no gradations in between, but the real world is analog. A light may have an infinite number of brightness settings, from on to off. Sounds range from barely detectable to painfully loud, like my little 3-year-old. In this lesson, we will learn how to connect the digital Arduino to the analog world, such that we can detect where an input is within its natural range and control an analog device by providing an output that matches its natural range. That's just a fancy way of saying controlling things that have variations. They're not either fully on or fully off. Up until now, all the work with the Arduino has been with digital inputs and outputs. A button is either pushed or not. An LED is either on or it isn't. The digital read statement returns either high or low, right? 5 volts or 0 volts. While the digital write statement either sets a pin to high or low. But the real world doesn't work that way. States have an infinite number of values. Here are some examples. The music was very loud. She spoke in a moderate voice. The piano played softly. And this one, Miracle Max from The Princess Bride says, "It just so happens that your friend here is only mostly dead." And this is the first clue. If you're going to stick with me through this video, the first clue for the secret password is that it has something to do with this line here. Okay, moving on. Analog input. In input mode, a digital pin is either high or low, never anything in between. This characteristic is referred to as binary, meaning it's either one thing or not that one thing. Okay. So like a push button, either it's pushed or it's not. Either a sensor sees light or it doesn't. But what if it needs to be measured not in binary, but something that can have multiple values between the binary extremes? For example, how far the knob is turned, how loud is the sound, how bright is the light, or how salty is the water. The Arduino Uno's analog pins A0 through A5 can measure a voltage between 0 and plus 5 volts to an accuracy of about 0.005 volts. This measurement is expressed between a number 0 and 23. So, how many gradations are there between 0 and 5, between high and low? Well, this tells you right here. It can measure to this many thousandths of a volt, and so those numbers come out to about 0 to 1023. That's how many increments you have between 0 and 5 volts. So that's the only really important number in this paragraph is this, 0 to 1023. That's what the Arduino naturally can do. Alright, here's a great picture. So between 0 and 5 volts, we've got 0 to 1023 numbers. What if we don't want to use 0 to 1023? What if we want to use 0 to 100? Well, good news, we can use this thing called mapping. And we can translate from 0 to 1023, and we can map that to a smaller range, like 0 to 100. So 0 would match with 0 here, and 100 would match with 1023 there. analog input output. While it's true that an analog port can accurately measure any voltage from 0 to plus 5 volts, the Arduino has no way of providing the output voltage in that range. The output voltage of the Arduino pin, whether it's analog or digital, is plus 5 volts or 0, nothing in between. But the C language does provide a way of writing analog values that approximate the range of 0 through plus 5 volts, and it does that by switching rapidly between 0 and plus 5 volts. So if it switches randomly between, then it can average out to something in between 0 and 5. That's what this says here. If half the time it's at 5 volts and half the time it's at 0, then the average comes out to 2.5 volts. Not only that, but an LED attached to that pin will produce half as much light as when the average voltage was 5 volts. By modifying the ratio of the time the output pin is set to 5 volts and the time it's at 0 volts, the average voltage can be set to any value from 0 to 5. The process of repeatedly setting an output pin high for a fixed time and then returning it to low like this, like what we just talked about, is called pulsing. And a single rise, wait, and fall cycle of the output voltage is called a pulse. The length of time the pulse is high is called the pulse width. Okay, and finally, using pulses alternating with periods of low output is called pulse width modulation. So here is pulse width modulation. It's pretty cool. So we've got a pulse here, which is the rise and fall, and it's this cyclical pattern. It's going 5 volts and then shutting off to 0 volts. 5 volts again, 0 volts. And the time that it's at 5 volts is the width, right? And that makes sense. If you look at this as a rectangle, this is the width of the rectangle. Here's the height, and here's the width. And so we call it pulse width modulation. That means we're modulating the width, or the amount of time that it's at 5 volts. Okay, so what would the average here be? So here's 1 second from 0 to 1. So half the time it's at 5, and then the other half it's at 0. So 5 plus 0 divided by 2 is 2.5. So this is an average voltage of 2.5 volts. Here's another example. This one, the width is a little bit shorter, right? It's been modulated to be shorter, so we've got 5 volts for about a quarter of the time. I think I have a better picture of this. Here we go. I broke it at 1 second into 4 parts. So there's a quarter of a second, there's a half a second, 3/4, and 1. So you can see a quarter of a second it's at 5 volts, and the rest of the 3/4 here it's at 0 volts. So let's add these up and find the average. So we got 5 plus 0 plus 0 plus 0, and that's 5 divided by 4 increments. 1, 2, 3, 4, 4 parts. 5 divided by 4 is 1.25. And that's our average voltage. Oh, important point here. Not all digital pins of the Arduino can do this. Some of them can, and they have a little tilde mark by it. And you can look at your Arduino and you'll see that little mark, and it corresponds to these pins here. Let me see if I have a picture of it really quick. This would be a good time to have a picture of the Arduino. That picture is kind of small. Okay, I don't have a good picture of it, looks like. So we'll go back. Okay, let's get another clue in here. Okay, second clue. Let's see. It's the name of one of the characters in that movie that was mentioned above. One of the characters. Okay, and I'll give you another clue later, so you got to keep watching. Okay, here we go. Lots of good terms here. The only thing you need to know for the quiz is that it goes from 0 to 23. You need to know what a potentiometer can be used for. So it can be used as an analog input device. It can be used to make a LED go brighter or dimmer, and it could also be used as a variable resistor. Okay, and it talks about that down here. See, potentiometer, a variable resistor that can be turned to select the resistance, make LED go brighter or dimmer. And it can also be used with an analog input pin, which is what this whole thing is about. Mapping. This is what we talked about before, where you can change the range of numbers. Instead of 0 and 10, 23, you could change it to something else. Pulse, we talked about that. Pulse width, we talked about that. Pulsing, we talked about that. Pulse width modulation, we talked about that. Okay. Alright. So, programming statements. Here they are. Analog read, analog write, and map was one of our statements. So analog read, of course, is going to read like a potentiometer, and it's going to get a number between 0 and 10, 23. Analog write will use pulse width modulation to provide an average voltage somewhere between 0 and plus 5 volts. And when it does this, it can use an integer between 0 and 255 is what it uses. Okay. So here we go. Okay. This part is interesting. You don't need to know this for the quiz though, so I'm not going to talk about this part. Here's the syntax for using the map function. Basically, you just start with your value, like whatever you're using, and then you start with your initial range, and you change it to what you want it to be. So let's see if we got a good example here. Yeah. So initially, so there's our initial value, and initially it was between 0 and 50. So now we've changed it to between 0 and 100. Alright, there's a potentiometer. If you took electronics, you know about these. So if you haven't, just read that paragraph. Same with this. This is all stuff you should know from electronics. And there we are. So this is what we'll do in class. We will practice with this circuit with a potentiometer, and we'll read some analog values, and we'll map them to some other values, and it should be pretty fun. Okay, the last clue is going to be the last name of the character that I mentioned earlier is going to be, it has the last name of one of our CTE teachers here at Shelton High School. One of our teachers here. So now I got to figure out who that is. Good luck.